All right, we're recording. Let me do a little intro. Okay, good morning, everyone. Dr. Brown is going to be speaking with us this morning about vegetable crop production. Dr. Brown is passionate about local sustainable agriculture. She takes a generalized approach to horticultural science, integrating plant pathology, plant physiology, entomology, genetics, soil science, and engineering to grow plants. She is the faculty leader for the Peri-Urban Vegetable Production Research and Extension Program at URI and teaches courses in vegetable production. She also conducts research on improving sustainability of vegetation on roadsides and in low-input, human-impacted environments, and using native grasses and wildflowers for these environments. And in addition to teaching and research programs, Dr. Brown is actively involved in fighting food insecurity at URI and in the surrounding community. So with that, Dr. Brown, if you can get started.
All right. Well, I will share my screen and we can start this conversation. Okay. So today we are going to start talking about different vegetable crops. There is absolutely no way I can cover all of this in just 2 sessions. I teach an entire semester class on vegetable production to URI undergrads, and even that doesn't cover everything. There's just a huge amount of information out there. So this is, definitely a case where you're starting on or continuing on a continuing journey of learning. But we will start out today, and we're going to focus today on vegetables that we grow for their roots, stems, and leaves. We will talk about the crops that we grow for their fruit next week. So just a little bit about categorizing vegetable crops, because there's lots of different ways to do this. A typical market farm is actually very different from most other types of farms in that it grows 50 or more different crops, each with multiple varieties and multiple plantings of each. So this is really, really complex. If you think about, commodity agriculture, most of those farmers are growing 1 to maybe 3 different crops if you count their cover crop. If you look at large-scale vegetable production, growers there often specialize too, and they're only growing, a few different crops. But market growers, because of our tendency to want to grow everything our customers are interested in buying, we tend to grow everything. And that amounts to a really large number of different plant species, different varieties, each one with its own needs, its own pests, its own limitations. And so it makes for a really complex and diverse ecosystem that we're trying to manage on our farms. So we do have a couple of ways of categorizing our vegetable crops as we think about them, and which one you use really depends on your objective. So you can categorize things by planting time, for instance. So we've got our spring crops that you might be looking at planting out now. So that would be things like lettuce, spinach, peas, onions. As opposed to the summer crops, the things you don't want to plant out until after the last frost when the soil is warm. When we're looking at things like spacing and planning the layout of the farm, we might look at the growth habit of our crops. Is it a big long vine that needs trellising or needs a lot of space to run? Is it a small rosette like a bok choy or a spinach? Or is it a large rosette like a kale or a bush? Obviously, I already said for this talk, I grouped them by the part eaten. And that is also very common, not only when thinking about presentation, but also if you look on pesticide labels, a lot of pesticide labels will group vegetables by the part of the plant that's eaten. So for instance, even though beets and chard are the same species, they are in different categories when it comes to the pesticide label. And there are products that are approved for use on beets that cannot be used legally on chard. There also, of course, the part eaten becomes important when you're looking at post-harvest handling. How do you store this crop? How do you wash this crop? How do you pack this crop? We can look at time to maturity. Is this something like a lettuce or a scallion that's going to be in the field for only a few weeks? Or is it something like a storage onion or a Brussels sprout that's going to occupy the space for a good part of the growing season? And then in many ways, the best way to group our vegetables is actually botanically by their family, genus, and species. So this refers to the scientific name, the scientific classifications. And the advantage of using botany to group our vegetables is that the botanical groupings are based on the genetic relationships between the different vegetables. And those genetic relationships are often what determine susceptibility to various pests, fertilizer needs, and sometimes the preferred growing conditions. So knowing what family a vegetable is in can be very useful to your planning. So for this talk and the one next week, I've done a top level grouping by the parts that we eat, but within each of these talks, I'm grouping the vegetables by family. All right, let's start off with a very brief vocabulary lesson just to make sure that everybody's familiar with the terminology. So today we're talking about vegetables where we eat primarily the roots, the stems, or the leaves. And most of these vegetables are true vegetables in that we're eating the vegetative or non-reproductive portions, and they tend to grow in what we call a rosette. And a rosette is a botanical term for a plant growth structure that consists of a large number of leaves with compressed internodes. So the internode is the space on the plant stem between the leaves. And when you look at a rosette, it basically appears like most of the leaves come out of the same place in the stem. So in many cases, like with this ornamental cabbage in the picture, or with a carrot, or a celery, or a spinach, you might actually think that there is no stem. And unless you cut that plant open and look really closely, you won't find the stem. And that's because the stem is completely compressed in terms of its height. But one of the things about rosettes, and this is true of all rosettes, whether it's a lettuce or the bitter cress that's probably flowering in your landscape right now, that's that little thing with all the white flowers, or a hollyhock, which is another rosette forming plant, is that when rosette forming plants switch to flowering, they do what we call bolting. And bolting refers to rapid internode elongation and development of flower stalks. Okay, and this is important in vegetables because bolting is often associated with the development of strong flavors and fibrous tissue. So once your crop has bolted or switched to flowering, it's generally not marketable. Okay, and this is true whether what you're growing is lettuce or bok choy or carrot or onion. Once that flower stalk develops, you no longer have a marketable crop, right? All right, so what crops are we going to talk about today? So we are going to cover 5 families. We're going to start out with the brassicas, formerly known as the Brassicaceae. This is the cabbage family, and it's our single largest group of vegetables. Then we will talk about the asters or the Asteraceae. This family is lettuce. It also includes the chicories, radicchio, escarole, and artichokes, but we're not going to talk about those today, just in interest of time. We're going to talk about the chenopod's or the goosefoot family. This is spinach, beets, and Swiss chard. We'll talk about the alliums or the onion family and the apiums or the carrot family. Other crops that we could put in this category include sweet potato, asparagus, basil, and rhubarb. And they're all in different families, and we probably won't have time to talk about them today. Okay, so we're going to start with the brassicas. And this is a very large family, as I mentioned, so I've broken it down further into different species. The general characteristics of the brassicas are all of these are cool temperature crops. Many of them can survive freezing, 26 degrees Fahrenheit or below. Some of them can actually be overwintered in the field, depending on where you are, and definitely can be harvested after the first snowfall or hard freeze. They also, as is not surprising for a cool temperature crop, are susceptible to stress or damage by high temperatures. And this is particularly true for the ones where the part we eat is actually the floral organs. They have small round seeds, your typical mustard seed, and these germinate really quickly. We use brassicas a lot for microgreens and baby greens because of this rapid germination. And it also means that brassicas in general respond very well to direct seeding. They are mostly annuals or biennials with a rosette growth habit and a strong taproot. Some of them can root as deep as 3 or 4 feet if your soil is that deep. And they will flower if they get exposed to temperatures below 50 degrees over the course of about a week, particularly if that happens in early spring. So even though these are cold tolerant, you don't want to be in too much of a hurry to plant out, particularly transplants in the spring. They have cross-shaped flowers. They used to be known as the cruciferæ for this characteristic. And the flowers are insect pollinated. This means that Brassicaceae will not self-pollinate. And most of the commercial varieties are hybrids. It is challenging to save seed for these. in part because they don't breed true. And they have multiple diseases that are spread in seed, particularly some very devastating bacterial diseases. This means that for brassicas, it's important to either use seed from companies that test their seed and only sell seed lots that have tested negative for things like black rot and other seed-borne diseases. Or if you're buying seed from a company that doesn't test, or you're not sure if the seed has been tested, you want to hot water treat it before you plant it. And you can find directions for hot water treating online. I believe it's UMass has an excellent guide to hot water treating vegetable seed on their website. It's important to do this because we tend, as market gardeners, to grow brassica crops throughout the entire growing season. And there are also a number of winter annual brassica weeds, which means that if you get one of these diseases on your farm, it can be very difficult to get rid of it because you've always got plant material or weed seed that could be harboring the disease. Okay, we're going to start with Brassica oleracea. This is the European brassica species. It is the species that includes the vegetables you're probably most common with most familiar with in this family: cabbage, kale, broccoli, collards, Brussels sprouts, cauliflower, and kohlrabi. All of these are actually the same species. And as a result, they can all share pests and diseases. Broccoli and cauliflower are annuals. All of the others are biennials. We actually want our broccoli and cauliflower to flower because what we eat are the undeveloped flower buds. But it's very important not to expose seedlings of broccoli and cauliflower to cold weather because we don't want them to flower too soon. These are large plants. They are mostly very heavy feeders. They need an abundance of nitrogen. They also need supplemental boron and plenty of calcium. So these are crops where you probably do want to put down that fertilizer or that manure or that high nutrient compost just prior to planting these. These are not crops that you want to grow on the residual nutrient from a previous crop. Brassica oleracea is very tolerant of transplanting. Not only can these be grown in plugs, but they can actually be seeded into a nursery plot and then dug and bare root transplanted. That is a particularly useful approach to growing the transplants for your fall crop, where it's warm enough outside, so you don't need that greenhouse environment, and you can plant them in a small area in the field or the high tunnel and have much less concern about remembering to water them than if you're growing in plug trays. You can plant these at very high density when you're growing them for transplants, and then just dig them and replant them. They take 4 to 6 weeks from seed to transplant, depending on the weather conditions and how big you need your transplant to be. Here in Rhode Island, the primary insect pests in Brassica oleracea are caterpillars, otherwise known as cabbage worms, and cabbage aphids. Here in southern New England, we have 4 different species of caterpillars, 3 species that are primarily spring and summer. And these are the green ones. And then the cross-striped cabbage worm, which is a late summer to fall species. That's the one that's yellow with black and white stripes. Those of you who are further north may not have the cross-striped cabbage worm. We did not have it here in Rhode Island until about 10 years ago. It's been moving north with climate change. The three green species, there are a lot of predators and parasitoids that control them, but they can be a significant problem on spring crops. Cross-striped cabbage worm can be a really severe problem on fall brassicas. And then cabbage aphids are mostly a problem on late fall brassicas. There are a lot of predators that control them, like all other aphids, but those predators tend to go into hibernation earlier than the aphids stop reproducing. So on Brussels sprouts and late fall kale and late fall cabbage, it can be very important to have good aphid control because it's very difficult to get the aphids off if you don't have good control, particularly for Brussels sprouts, where they like to get in between the leaves on the individual sprouts. For those of you in northern New England or in northern New York, you also need to be aware of the Swede midge, which is an emerging pest. We do not have it here in southern New England yet, but it is something to look up on the extension website and be aware of. The primary disease problem on Brassica oleracea here is the alternaria fungus. There are actually 3 different species of this fungus, and it infects leaves and also the heads of broccoli and cauliflower. Alternaria can be seed-borne, but it also spreads on the wind, and it's a particular problem, again, with fall crops where you've got that humid, moderate climate. It's not a problem when the weather's really dry. It's not a problem when the weather's really cold, but sort of in that transition period. And it's a real problem in that it can cause storage rots as well. So this is one where you really have to pay attention, and you may need to use fungicides that aren't approved for organic production to control it, particularly in Brussels sprouts, which have a very long growing season. For those of you in heavier soils, you need to be aware of the existence of clubroot. This is a soil-borne fungus. If you have it, you have to grow clubroot-resistant varieties. If you don't have it, you don't want it. So this is one where it pays to grow your own transplants if you don't have clubroot, so that you don't acquire clubroot from someone else. Okay. So this is
Dr. Brown,
yes.
Are you going to be able to share these slides with us? Okay,
yes.
Great. Thank you.
So this table is an overview of the different species. And one of the things I'd like you to notice about the Brassica oleracea is that despite the fact that they're all the same species, they vary enormously in size and the amount of space that they need. So kohlrabi is a short season crop, 37 to 52 days from direct seeding, and it's a small plant. You can space kohlrabi 4 to 6 inches apart in the row with a foot or less between the rows. In contrast, Brussels sprouts is 100 days or more from transplant to maturity. So it's going to be in position all summer. And Brussels sprouts plants get very large. They need 4 to 5 square feet per plant or more. So this means that you're looking at a single row in the bed, and you're looking at spacing the Brussels sprouts plants 2 to 3 feet apart. The further apart you can space your Brussels sprout plants, the better, because it makes it easier to control insects and diseases on these. And since they're in position for such a long time, that's really important. Another thing to remember with these crops is that it may be tempting to dedicate one space, one section in your field to this species. But you actually don't want to do that, because some of these you're going to be succession planting. So for instance, kohlrabi, you could plant, every, say, 2 to 4 weeks. Broccoli, which is 60 to 65 days from direct seed, you're going to want to plant a range of different varieties that mature at different times. And you also have a spring, an early summer, a late summer, and a fall crop. You don't want to plant your late summer and fall broccoli near the Brussels sprouts that have been in the field all summer, because the Brussels sprouts will be harboring pests that can get on that late fall broccoli. You also don't want to plant your late season broccoli in the same space that you planted your early season broccoli. Again, because you can have pest carryover. You want to try to keep these as separate as you can, given the limitations of your production space. Some of these, like cauliflower and cabbage, each plant can only be harvested once. Others, like kale and collards, if you harvest individual leaves, you can actually harvest off a single planting for an extended period of time. Kale and collards also are not particularly sensitive to heat, and they can withstand hard frost. Broccoli and cauliflower, on the other hand, are very sensitive to heat. Cauliflower is basically impossible to grow in the hottest part of the summer. And by this, I mean, you don't want to have it maturing then. So you don't want to be harvesting it in July and August. With broccoli, you may be able to grow it through the entire summer, but you need to pay very close attention to the varieties and make sure that you use heat tolerant varieties for summer and cold tolerant varieties for your late fall planting. Also note that kale and Brussels sprouts are often harvested after the first frost, because that improves their flavor. Although kale has gotten so popular that people are harvesting it pretty much continuously. All right, let's see. So that's what I have about that. Are there questions about these Brassica oleracea vegetables before we move on? If you've got your hand up, I may not be able to see it, so just go ahead and speak out. Okay. Let's move on. So the next group in the brassicas are Brassica rapa. And this is primarily an Asian species. So where Brassica oleracea is native to Europe, Brassica rapa is mostly native to Asia. It includes the Chinese or Napa cabbage, the pak choy, mizuna, turnips, rapini or broccoli rabe, tatsoi, Kamatsuna, and others. Most of these are annuals, and the ones that are biennial are much less strongly biennial than Brassica oleracea. So what that means is that it's much easier to trigger them to bolt. Okay. They are much faster growing and generally smaller plants overall than their Brassica oleracea cousins. And they have thin, non-waxy leaves. They also require significantly less nitrogen. And in fact, if you fertilize these the same way that you fertilize your Brassica oleracea, you're going to have problems. So these are ones that you can actually grow on the residual fertility in a field after you've harvested another crop. Okay. They are much more sensitive to frost than Brassica oleracea because the leaves are thin and they don't have that heavy waxy coating. They suffer more from frost damage, but they can be grown over the winter in high tunnels, and they're very well suited to baby greens production. Many of our baby brassica greens are in this group. These are also sensitive to root disturbance. So unlike Brassica oleracea, you cannot bare root transplant these. You want to direct seed them or use plug trays or paper pots for these. The primary insect pest of these is flea beetles. Flea beetles really don't damage Brassica oleracea very much because of the waxy leaf coating. And in contrast, caterpillars are less likely to damage Brassica rapa than they are Brassica oleracea. Cabbage root maggot is also a problem in these, primarily on turnip, because we eat the root there. And they tend not to get alternaria to the same extent as the Brassica oleracea either. However, they are very susceptible to bacterial diseases, and that's particularly true with Chinese cabbage. The other vegetables in Brassica rapa tend to be mostly disease-free. But Chinese cabbage is the tricky one here. So here's a table showing these. So Chinese cabbage is the largest, and it requires 2 to 3 square feet per plant. It also has some of the longest maturity, up to about 60 days. It only gets harvested once, and it stores really well. So you can actually store Chinese cabbage all winter if you can keep it from drying out. You need to know that Chinese cabbage is very sensitive to excess nitrogen. It causes a disorder called pepper spot, which causes little black specks in the leaves and the petioles. And rapid growth of Chinese cabbage can also cause tip burn, which is calcium deficiency in the leaves inside the head. And this is particularly a problem in warm weather. So you do have to watch your fertility with Chinese cabbage and make sure that you have sufficient calcium. Bok choy is a lot smaller than Chinese cabbage. It is much easier to grow. It will bolt in long days, so it can be tricky to grow in the May-June time period. You have to be really careful to harvest your early spring plantings before we get much into May, and to make sure that the later crop is not exposed to extended cold nights. Turnips are grown for their roots. They're planted at fairly high density. They're pretty easy to grow, except that particularly in the spring, you want to cover them with row cover to protect from cabbage root maggot. And your extension service should be able to provide you with updates on when the cabbage root maggot emerges in the spring. It's a temperature dependent emergence. There are really good models based on growing degree days. And basically you want to make sure that any brassica root vegetables that are still in the field or the high tunnel at this point get covered to protect them from the flies that lay the eggs that become the root maggots. Rapini does not transplant well. It's one where you actually want it to bolt because we're eating the immature flower stalks. It's relatively large, but a lot smaller than broccoli, even though in many seed catalogs, rapini is sold together with the broccoli. It's actually a different species with different requirements. And then the other Asian greens I grouped together. Most of these we grow as baby greens. And again, these do not transplant well. If you transplant them, the stress tends to trigger bolting. So these are things that you really want to direct seed, and you probably will need to cover these to prevent flea beetle if you're seeding them during the late spring through the early fall. If you're growing them for winter and early spring, the flea beetles aren't active. So questions about Brassica rapa?
Yeah, hi, Dr. Brown. A question
Yeah.
for you in regards to all brassicas in regards to nutrients, or excuse
Yes.
me, not nutrients. I just forgot what I was going to ask. Nutritional value.
Okay.
Is there anything in particular about these crops that is a selling point for, pardon me, for our customers as it relates to nutritional value?
Well, so kale has been labeled a superfood. Superfoods come and go. And it is true that all of these greens are very good for you. They have, a lot of antioxidants. There was some work done back in the aughts that sort of triggered the whole kale superfood movement that showed that seedlings, so like microgreens or sprouts of Brassica oleracea, contained a whole bunch of anti-cancer compounds. However, there was subsequent research, which wasn't as widely published, that showed that they also contain a whole bunch of cancer-causing compounds. So like with most plants, if your goal is to prevent cancer, it's probably a wash. However, they're very much a part of a nutritious diet, and they're definitely still good for you. Brussels sprouts seem to be having a moment. Nobody used to eat Brussels sprouts, and now they're on the appetizer menu of all the fancy restaurants, usually wrapped in bacon or soaked with maple syrup or otherwise cooked in ways that negate most of their nutritional advantages, but they're popular. Kimchi and other fermented Asian foods are also apparently having a moment because everybody is worried about their gut biome, and eating fermented foods is good for your gut biome. The primary ingredient in kimchi is Chinese cabbage. So all of these are selling points, and it really depends on what your customers are into. I would also note that broccoli is one of the most popular vegetables. There are lots of people who will eat broccoli who wouldn't touch any other brassica with a 20-foot pole. And cauliflower is having a bit of a moment because riced or powdered cauliflower can be used as a substitute for rice, potatoes, even flour in gluten-free or carbohydrate-free diets. So you find, for instance, a lot of riced cauliflower being sold in sort of the healthy food sections of the produce aisle. And that's for people who are trying to avoid carbs. They're trying to eat paleo, things like that. And then it's also used in things like gluten-free pizza crust. So it's all marketing.
Great. Thank you. Good information.
Sure. Other questions? Okay. Moving on, we have a couple of other brassica species that only have one or a few vegetables in them, so no tables. One thing to note is Russian kale or Siberian kale. You will find this sold together with the Brassica oleracea kale in the seed catalogs. It is not Brassica oleracea. It is Brassica napus. It's a separate species. It's native to Siberia, and it's a much faster growing kale. It's the kale that you want to use if you're growing baby kale greens. Okay, you don't want to use Brassica oleracea kale for baby greens. You want to use Brassica napus. It's also much more tender than standard kale. This means that it's good for use in kale salad. It's good for very light cooking, so very light sauteing, for instance. It also means that it's much more frost sensitive. So you're not going to be able to overwinter Russian kale the way you can overwinter regular kale. And by regular kale, I'm talking about curly kale, I'm talking about the large smooth leaf kale, and I'm talking about the dinosaur or lacinato kale. They're all Brassica oleracea. You can tell Russian kales because the leaves tend to be pointed, the lobes on the leaves, and it has a much narrower petiole on the leaf. It also is not as waxy. Rutabaga, interestingly, is the same species, Brassica napus, but it looks much more like Brassica oleracea. It is a larger and slower growing crop than turnip, but otherwise is fairly similar in how it's grown. You need to give it more space. It's pretty much susceptible to the same pests as turnip, less susceptible to flea beetle, similarly susceptible to root maggot. With rutabaga, especially if you're growing large roots, you again need to pay attention to calcium and boron to prevent hollow heart and water soaking of the center of the root, which can be caused by either a lack of calcium or a lack of boron. Radish is Raphanus sativus. It can basically be grouped into two types of radishes. the ones that you're probably most familiar with from the produce aisle, so these are the small, round, usually red, but not always radishes, are known as spring radishes, although they can be grown whenever the weather's not hot. They are true annuals. They grow really rapidly and will bolt very quickly, particularly in the heat. Winter radishes, otherwise known as daikon, are annuals or biennials. So these can be grown for a very long period in the fall. They can also be grown in the spring, but you need to choose your varieties carefully. Arugula is Eruca vesicaria or Eruca sativus, depending on the type. It's an annual that's grown for its baby leaves. And then mustard greens are Brassica gensea. It's the same species as we use for mustard seed. It's much more tolerant to heat and sensitive to frost than the other Brassica species. And we mostly grow mustard greens for baby leaves, although they are grown for bunching in the southeastern United States. And if you have either a lot of customers who grew up in that culture, or customers who emigrated from Africa or India, you may have a market for bunching mustard greens. And all of these are best direct seeded. They don't transplant well. So here's a chart for them, giving you an idea of the spacing that you need. You'll notice that most of them can be grown quite close together. And that's particularly true if you're growing them for baby greens. Arugula and mustard greens for baby greens grow really rapidly. They grow much faster than lettuce. 18, 21, 28 days. And so you want to plant them every 2 weeks. With spring radish, again, it matures really quickly, just 21 days, and you want to make sure you harvest them really promptly because they will get woody and unpleasant if you leave them too long. Daikon, on the other hand, takes about 50 days, and if you're growing daikon in the fall, you can actually leave it for an extended period of time. However, the roots do not tolerate freezing. So you do want to harvest it before you have a ground freeze. Okay, so that is all that we have on the mustard family. Do we have questions about these before we move on? Okay, so let's do the aster family, which is just lettuce. And then I don't know, Trish, do we want to do a break? We'll be an hour in.
Sure, that'd be good.
Okay, so let's talk about the aster family. So this family, as the name suggests, includes a lot of flowers. So the only vegetable we're going to talk about in this family is lettuce. But if you're growing cut flowers, you're probably going to have a lot of aster family plants on your farm. So things like dahlias and sunflowers and rudbeckia and chrysanthemums and daisies are all in this family. Okay, so lettuce or Latuca sativa is the most common aster family crop. It is, of course, a very major crop. There are many, many different market classes and varieties of lettuce. Unlike the Brassicaceae, lettuce is self-pollinated. And so it's very easy to save seed from lettuce. And there are literally hundreds of heirloom varieties, as well as a large number of modern varieties, none of which are hybrids. So you can actually save seed of all of these. Lettuce can be grown either for baby leaf harvest or for harvest as mature rosettes. Some of these mature rosettes will actually form heads. Others are what we call loose leaf lettuce, just form rosettes. And in terms of production, there's not a lot of difference. Lettuce is very tolerant of transplanting. However, lettuce seed will not germinate if the soil is 80 degrees or higher. Lettuce undergoes dormancy at that temperature. So while you can direct seed lettuce, it is often transplanted, particularly for mature rosette production. It germinates most quickly at a temperature of about 68 to 70. Lettuce is a true annual, and warm temperatures will cause bolting. Lettuce does not need to be exposed to cold to trigger bolting. Simply leaving it in the field too long will trigger it to bolt. Also, any sort of stress can trigger bolting in lettuce. Lettuce is also very susceptible to bottom rot, which is caused by the soil-borne disease rhizoctonia. Rhizoctonia is everywhere, so you're not going to eliminate it if you're growing lettuce in the soil. Your best solution is to use cultural practices to minimize excessive wetness and minimize contact of the lower leaves of the lettuce with the soil. Aphids are the primary insect pest in lettuce, and really there are not a lot of pest problems other than aphids. The other thing to note about lettuce is that it's a relatively light feeder. It makes a good follow-on crop, but it's sensitive to boron. So you don't necessarily want to plant lettuce right after some of these brassicas where you've applied excess boron. Okay. Too much boron will cause lettuce to be stunted and chlorotic looking. So the two production methods for lettuce are rather distinct. When you're growing lettuce for baby leaf production, so this is for salad mix, it's going to be direct seeded at very high density using raw or unpelleted seed. And we usually use heirloom varieties for this because you're using a huge amount of seed and you want to use inexpensive seed. So with baby lettuce, you're seeding anywhere from 12 to 30 seeds per foot, depending on whether you're doing a single line or a band. And you're looking at about 28 days from seed to harvest, maybe a little bit longer in early spring or late fall. You can mix varieties in one plot. You can actually buy pre-made seed mixes, or you can plant single varieties and mix the varieties after harvest. A lot of growers like to do this because the different varieties may grow at slightly different rates. Also, if you're adding other species into your mix, so maybe you're growing Brassica rapa greens, or you're growing chard or spinach or herbs, It's best to grow those in separate plots and mix in the post-harvest stage because of, again, different times from seed to maturity. The big advantages of baby lettuce production, particularly for smaller market farms, are that you have very rapid turnover. The lettuce is only in place for a month. You have minimal problems with disease because the lettuce isn't in place long enough to get disease. Again, minimal problems with insects, and you can generally harvest it before it bolts. The biggest disadvantage with baby lettuce, and you can sort of see this if you look closely at the picture on this slide, is weeding. Baby lettuce is planted at really high density, which means that you're probably going to have to weed with your fingers. You can see a picture of a person in the background of that picture. This is an incredibly slow, tedious task, and it's not uncommon for market growers to lose entire plantings of baby lettuce to weeds because they don't get them weeded at the right time, and then they get swallowed up. There's no way to use mulch with baby lettuce, and it's very difficult to even use a hoe, let alone any sort of mechanical cultivator in there. The other disadvantages are that because baby lettuce is a baby leaf, it's extremely tender. This gives it a very short shelf life after harvest. So for instance, if your market gets rained out, you probably can't save the baby lettuce in the cooler for the next market, unless it's like the next day. Also, because of the high density that we're growing baby lettuce at, it's not amenable to transplanting. So if your soil is really hot, for instance, because it's July or August, you don't really have that option of germinating the seed indoors in a controlled environment. You can try to use shade cloth or irrigation or some other method to cool your soil, but you don't have the option of simply moving to a better environment for germination. And this is why many growers prefer full-size lettuce production. In full-size lettuce production, the entire rosette is harvested and sold as a head, or if you're growing the multi-leaf one-cut heads that have very small leaves, you can actually cut the rosette just above the growth point and sell the leaves as salad mix. Okay, so you have that option. Depending on your state and how they interpret the switch from produce handling to processing, you may also have the option to cut the whole rosette, bring it in, store it in your cooler, and then cut the rosette into the salad mix post-harvest. That's one where you want to check with your regulatory agency, because some states say you need a processing permit to do that and other states don't. Full-size lettuce production, depending on the type, is 42 to 70 days from transplant to maturity. Loose leaf and one-cut types and mini heads are generally closer to 42 to 55 days, where full-size romaine and iceberg or crisp head types are going to be closer to 70. The lettuce seed for full-size production is more expensive than what you're going to use for baby production. It's often primed and pelleted to improve germination. And the plants are started as transplants in plug trays or paper pots. Because you can start the transplants in an optimized environment, you can expect in many cases to get 99% germination on this. So you don't need to overplant extensively. Spacing is pretty flexible. It depends in part on what you want for your full head size. Mini heads can be spaced as close as 6 inches apart in the row and 6 inches apart between rows. Full-size heads, you're looking at 12 inches apart in the row and anywhere from 18 to 36 inches between rows. One of the big advantages of full-size lettuce production is that because it can be transplanted, it also can be easily mulched. You can see in this picture, we were growing spring romaine on black plastic to warm the soil and speed growth. For summer and early fall crops, you can use white on black plastic to cool the soil and help give it a cooler environment. Plastic also can greatly reduce bottom rot by avoiding leaf contact with the soil, and raised beds can increase drainage, which also reduces bottom rot. You can also use organic mulches with lettuce, so things like compost or leaves or straw. And these can be particularly useful for fall production because it will keep the soil warm longer. And so the lettuce will actually mature more quickly. In general, growers who are growing full-size lettuce use modern varieties. You can use heirlooms, but the modern varieties have superior heat tolerance. They often have superior disease resistance. And there are a lot of popular new features. So for instance, there's been a lot of effort to develop mini heads that are popular with smaller families and individuals, as well as the one cut growth habit, which is actually patented and only available in modern varieties. So, you know, this is definitely a place where you want to trial the newer types and not just rely on the heirlooms. Advantages of full-size lettuce production. You can start your seeds in optimal conditions. It's much easier to weed even if you're not using mulch. You can space these far enough apart that you can mechanically cultivate. You shouldn't need to hand weed. You can get in there with a hoe, because by the time you transplant in, your plants are basically at the baby lettuce stage. It's also much faster to harvest entire rosettes, particularly if you're harvesting by hand, you don't have an automated lettuce harvester. And the mature leaves have a much longer shelf life after harvest. Heads can hold in the field, or they can store for several weeks in the cooler. And even lettuce mix, salad mix, made with the one cut varieties has a longer shelf life than salad mix made with true baby. And that's because mature leaves have thicker cuticles, they have heavier cell walls, and they're just much more resilient to handling. They don't bruise as easily, and they don't dry out as quickly. The big disadvantage, of course, is that your plants are in the field a lot longer. And that means that you do have a greater chance of disease or of bolting. Some of the types, particularly the true head-forming types, are very susceptible to tip burn and heat injury. That's one reason why heat tolerance has been a major breeding goal. And it's also more difficult to time your successions. And this is simply because you have to plan further ahead, right? It's much easier to predict 2 to 4 weeks ahead than it is to predict 6 to 8 weeks ahead or longer. And so it's easier to make sure that you have a continuous supply with baby lettuce than it is if you're growing full-size heads. But this is somewhat counteracted by your greater ability to store your full-size heads after harvest. And what I'm seeing is that as many market growers gain experience, they switch from baby lettuce production to full-size head production, often using these one-cut varieties, simply because of the labor savings of not having to spend all that time hand harvesting baby lettuce. Other growers don't switch and instead invest in mechanized harvesting equipment. So that is what I have on lettuce. Are there questions about lettuce, or is anybody super eager to talk about chicory? All right. I'm not hearing anything, so shall we take a brief break?
Yeah,
Okay.
that sounds good. Is 5
All
minutes
right.
okay? Or
Yep.
okay. See everyone back in 5.
All right. Go ahead and share our screen again and we can continue. Okay. So our next family is the Chenopodiaceae, or the goosefoot family, and this is beets, chard, and spinach. So beets and chard, as I mentioned earlier, are the same species, Beta vulgaris. Beets have simply been developed primarily for the root, where chard is developed for the petiole and the leaf. Both of these are biennials, so they require cold treatment to flower. And this is really useful because you can grow Swiss chard all summer long. You can also grow beet greens all summer long. And in fact, there is a heirloom variety of beet that was developed for its greens that's known as perpetual spinach, because it just keeps producing all season long. Beet roots have the best quality when they're grown in cool weather, but they can be grown throughout the summer. And as I mentioned, the greens are very heat tolerant. The greens, however, are not as tolerant of frost as brassica greens are. Beet seed is actually a fruit or a seed pod with multiple seeds, which means that you generally are going to need to thin. The other thing is that seedlings, particularly in beet, are very susceptible to damping off. So if you are direct seeding, you want to either use fungicide treated seed or seed to 200% of the desired stand. So that means basically put down twice as much seed as you think you'll need. For beets, you're looking at 10 to 12 plants per foot of row. For chard, it's 4 to 6 inches between plants for bunching, but a much higher density for baby greens that you're going to include in your mix, your salad mix. Swiss chard transplants really well. And it's much easier to establish Swiss chard from transplants. Beets can be transplanted. The paper pot transplanter was actually developed in Japan for transplanting sugar beets. But you get a better root shape if you direct seed. So beets are tricky in that respect. A lot of growers do transplant them, particularly organic growers, because of the difficulties with poor emergence of the seed and also with weed control in the seedling stage. But you don't get a nice round root from a transplanted beet, really. Beets do benefit from supplemental boron. Chard has less of a boron requirement than beets do, but you will still get better plants if you make sure to have a sufficiency of boron. Okay, the other crop in this family is spinach. Now, spinach, unlike chard, is a true annual. And spinach will bolt very easily if it gets stressed. You can transplant spinach, but you have to be sure to avoid all stress when doing so. So it's not generally a preferred crop for transplanting. Most spinach on the fresh market today is grown for baby leaves, and baby leaf spinach is 24 to 28 days from seed. Partly this is because it's easier to mechanically harvest baby leaf spinach, and partly it's because you avoid a lot of problems with bolting. Bunching spinach is mostly grown for processing, but depending on your market, depending on your customers, they may be interested in the larger leaves. Spinach is really cold tolerant. It can be grown all winter long in high tunnels, even in zone 5. So a lot of growers who can't grow lettuce or brassica greens through the middle of the winter can grow spinach. Spinach seed is really short-lived, and it's very prone to decay and damping off. It also has very poor germination in warm soil. So you want to use fresh seed. You want to consider using treated seed if you're growing in cold soil. So for instance, your spring spinach crop. If you're planting into warm soil, you want to chill your seed for at least 24 hours before planting and then provide shade. And you definitely, again, want to really overplant spinach seed if you have any doubts as to its freshness. You also need to match spinach varieties to the planting season, because baby spinach is another one of these staple crops for market growers. We now have baby spinach varieties for early spring, late spring, early fall, late fall, and overwintering. And you don't want to, for instance, use a late fall variety in the late spring, because it will be very susceptible to bolting. And similarly, early or spring varieties may be more heat sensitive than varieties intended for fall and winter production. So it's important to pay attention to matching the varieties to the planting season with spinach. Okay, now we do have some significant disease issues in the chennapods. In beet and chard, our #1 disease is Cercospora leaf spot. This is a fungal disease. It's seed-borne. It contributes to the damping off problem, particularly in beets, but it also can infect a number of weed species, including lamb's quarters, which is related to spinach and beets. And Cercospora leaf spot is particularly bad in warm, humid conditions. So late spring through early fall. The best way to manage Cercospora leaf spot is resistant varieties. There are a number of resistant varieties available for red beet. There are not a lot of resistant varieties for yellow beet. There are a number of fungicides available for beets, but most of the organic fungicides that are labeled for beet cannot be used on chard. And the reason for this is, of course, that for chard, we eat the leaves. Cercospora mostly affects the leaves, so you can handle a fairly heavy Cercospora infection in beets, but there's a much lower tolerance for it in chard. White chard and yellow stem chard are less susceptible to Cercospora than red chard. And there are some resistant red chard varieties out there. Unfortunately, right now, none of them are available as untreated organic seed. So that can be an issue if you're certified organic. For spinach, the major disease is downy mildew. And downy mildew is a huge problem in the large-scale spinach production areas of the West Coast. So there are a lot of resistant varieties available, but if you've ever wondered why the range of spinach varieties in the catalog keeps changing, it's because new strains of downy mildew keep originating. And so then they need new resistant genes to stay ahead of it. We don't have a lot of problems with downy mildew except in the fall winter tunnel, mostly in the October-November period. We do have some other fungal leaf diseases in spinach that don't occur out west. And unfortunately, there's no good resistance information for controlling them. So your best way to manage disease with spinach is to do baby leaf spinach, lots of successions, and try not to plant your fall spinach in the same place as you planted your spring spinach, or your spring spinach in the same place you planted your winter spinach. The primary insect pest of these is the leaf miner. It's a fly larva. It affects all three of these. Fortunately, here in New England, we generally only have one generation. Occasionally, we get a second fall generation down here in Rhode Island. The easiest way to control it is with row covers. With chard and beets, you can also remove the damaged leaves. You can even go so far as to mow the foliage down and let it regrow. And because there's only the one spring generation, the regrown material will be clean. Even if there's a second generation, it doesn't occur until September. So you can generally get a clean harvest despite having leaf miner damage. Obviously, with spinach, you can't mow it and expect it to regrow. It will simply bolt. So questions about spinach, beets, chard? Okay, moving on to the alliums. This is the onion family. So all of these are in the same genus. They're all in genus Allium. They're all quite closely related. They are grown either for the bulbs or for the leaves. Chives and garlic are perennials. All of the others are biennials. Bulb development in garlic, onions, and shallots is controlled by day length, as is scape development in garlic. So what does this mean? This means that here in New England, for summer production, you need to grow intermediate or long day varieties. And if you're way up in the northernmost part of Maine, you may not be able to grow intermediate varieties. If you're going to try to grow onions in the high tunnel for overwintering, you need to grow short day varieties. Because long day varieties will only bulb under long days. It also means that planting time is important. So if you look at variety descriptions, they may say that an onion variety is 90 days from seed to transplant. And you may think that that means that you can direct seed it in May like you would rutabaga, which is also 90 days. But you can't. You have to start your onions indoors as transplants no later than the beginning of April, and ideally earlier than that, because you want them to have as many leaves as possible before the day length gets long enough to initiate bulbing. Because the number of leaves at the point where bulbing is initiated will determine the size of your onions. Okay, and the same goes for shallots. Similarly, while you can plant garlic in the spring, you will have smaller garlic bulbs than if you planted your garlic in the fall. And it all relates to the number of leaves that are present when bulbing is triggered. Okay. Now, we usually grow leeks from transplants, even though they don't bulb, because leeks are very long season. But you could theoretically grow leeks from direct seed. We do grow scallions from direct seed because scallions are very quick to go from seed to harvest. And again, we're not worried about bulbing. We actually don't want bulbs on our scallions. So that whole issue of day length is not a problem. Garlic, as you probably know, does not set true seed. It is vegetatively propagated using cloves. Chives can be grown from seed, but they take a very long time. And so more commonly, the clumps of chives are simply divided and transplanted. All right, here's a chart that helps you know when to plant. So for onion, if for your summer production, you want to seed indoors in February or March, transplant in April. You can even transplant earlier if you can get into the field. And you want to space 1.5 to 2 inches apart within the row. If you space them further apart, you will get jumbo onions. And most people don't want jumbo onions for the long day types. You want to harvest them when the tops fall over. That's usually August. Now, if you're growing short day onions for overwintering, you want to plant them in September or October. And again, this is transplanting. You would have started your seeds in a shade tunnel a couple months before that. For garlic, we usually plant in October or November. You want 4 inches apart within the row, and you want to harvest when 2/3 of the leaves turn yellow, which is usually sometime in July. If you're growing hardneck garlic, which is the most common here in New England, you also want to cut your scapes in July. There's 2 reasons to cut your scapes. One is that you can sell them. The other is that you want the garlic plant to put all its energy into the bulb and not into developing little teeny tiny bulbils in the scape. Shallots get treated like onions, and they keep a lot longer than onions. So one reason to grow shallots is that your onions are going to be losing quality in storage by about February. Your shallots will stay nice in storage well into May or even June, by which point you can be harvesting green bulb onions for market from your onion planting. And a green bulb onion is simply an onion that's already bulbed, but it hasn't started drying down yet. Leeks also get planted like onions, but further apart, 4 inches within the row and 30 inches between rows, because these plants get really big. And they are harvested 90 to 120 days after seeding. So these are going to be in the field all summer and through the fall. Leeks are extremely cold tolerant. And usually with leeks, we control the weeds by hilling, because that also increases the blanched shaft length. But you can grow leeks in plastic mulch with raised beds. You just want to make sure to plant them really deep. Scallions can be seeded continuously from April through September. You want 12 or more seeds per foot. And basically they can be harvested whenever they get to the desired size. Obviously, scallions cannot be stored. Leeks can be stored in cold storage for a while. They can also be covered and left in the field because they will actually tolerate quite a bit of frost. Okay, issues with alliums. The number one issue is that you don't get a big crop canopy with these. So weeds are always a problem. Many growers have switched to using mulch, including plastic mulch. If you're using plastic mulch with onions, you do want to pay attention to the variety, because some varieties will form their bulbs under the mulch. Others will form their bulbs on top of the mulch. You want your onions to bulb on top of the mulch, because bulbs that are under the mulch in that really warm, humid environment are much more likely to rot. Alliums also have very shallow roots. They do not tolerate drought, and they need regular application of nutrients. You need to cover your alliums in spring and fall to prevent allium leaf miner, at least here in southern New England. I don't know if allium leaf miner has made it to Maine yet. But here in Rhode Island, we definitely have it now. This is a new pest, and it will completely destroy your crop. It burrows through the leaves into the bulbs and leads to massive bulb rot in onion and garlic. In leeks, the problem is that the entire shaft gets full of the larvae, and nobody wants to eat that. In the summer, you need to control onion thrips, because they damage the foliage and will increase botrytis infection. And botrytis infection of leaves can lead to bulb rot of onions and garlic. The primary disease is purple blotch, which is caused by an alternaria, but this is a different alternaria from the one that affects brassicas. It's worst on leeks because of the big wide leaves, and also because leeks are in the field through the fall. For garlic, this is really important. Do not buy your planting stock at the grocery store. You want to buy certified garlic seed, or seed that you know is clean. So if you are getting your garlic seed from a neighbor, make sure that you trust that they have a clean operation, because there are a number of really nasty pests that spread in garlic seed. One is the bulb mite. This is a mite related to a spider mite. It lives in the garlic bulbs, and it will destroy your crop. Another is the bloat nematode. This is a nematode that lives in the bulbs and in the soil. It will destroy your crop, and it will infect your soil, so you will have to move your garlic. And the final is white mold. White mold is a fungus. Again, it will destroy your crop, and it will live in the soil. The best way to prevent these problems is clean seed. Okay, I can't stress that enough. It is very easy to save your own garlic seed, and garlic does have a certain ability to adapt to the microclimate of your farm. But you want to start with seed that you know is clean. And so that way you don't introduce anything to your farm. Saving your own seed from year to year is fine, because you either have the pest already or you don't have the pest. Excuse me. The other thing to remember about alliums is that onions, garlic, and shallots need to be cured, which means the tops thoroughly dried, before you cut the tops off and put them in storage. This is very important to prevent botrytis infection and bulb rot. Okay. So questions about alliums before we move on? All right. The last group we're going to talk about is the Apiaceae, which are the carrots and their relatives. Carrots and parsnips are biennials that we grow for the taproot. They need very deep soil. Celery is an annual that's grown for its swollen petioles. Celeriac is the same species, but is grown for the stem. Even though it is sold as celery root, it is actually a stem. Fennel is an annual grown for swollen petioles. Parsley is a biennial grown for the leaves. And cilantro and dill are annuals grown for their leaves. Celery, celeriac, fennel, and parsley can be transplanted, but all of the others need to be direct seeded. Parsnip has the longest maturity. It's about 120 days. Parsnip seed has very poor germination, so you want to seed at 200% of stand, and you want to either buy fresh seed every year or store your seed in the freezer. Carrot can be anywhere from 36 to 75 days. Storage types, which are also the longer maturing ones, can store for 4 to 5 months. And disease-resistant varieties are very important for this fall storage crop. Parsley can be transplanted. It takes about 75 days, and it can be harvested continuously. Celery is 75 to 80 days. Celeriac is 95 days. Celery is much harder to grow than celeriac. It's extremely sensitive to both stress and frost. Celeriac is not as sensitive to frost. It's not as sensitive to stress, but you want to make sure to provide sufficient boron and calcium. Cilantro is only 50 days from direct seed, and you want to plant successions because cilantro will bolt very readily. Fennel is 50 to 90 days. It'll store for 1 to 2 months, and high soil temperature causes bolting. So the fall crop is often best transplanted. It is also frost sensitive. Dill is like cilantro, but it is more frost sensitive. And you want to look for bolting tolerance in both cilantro and dill, as well as planting successions. Diseases. There are a number of leaf spot caused by fungi, Alternaria, Cercospora, and Septoria, that are problems in carrots, cilantro, dill, and fennel. And there are resistant varieties available for carrots and cilantro. They are particularly important to use in the fall when these diseases are the worst. You can tolerate a fair amount of leaf spot in carrots since you're not using the greens, but too much of it will reduce the sweetness and size of your carrot roots. Anthracnose is a problem in celery. It does not seem to overwinter here in New England. So if you are having problems with anthracnose in your celery, I suggest changing your seed because it can be seed-borne. Rhizoctonia, the same one that affects lettuce, can cause bottom rot of celery, fennel, and parsley. Plastic mulch and raised beds are useful here, as well as just making sure that your soil is well drained. Carrot rust fly is a problem in some areas, including northern New England. You can delay planting until after rust fly emergence in May, and you can use row covers on your early season plantings to exclude the adults. The rust fly is similar to the cabbage root maggot in that it lays the eggs in the soil near the carrots, and the larvae burrow into the roots, causing rusty colored damage. All right, that is actually all I have. So we can open it up for questions.
Hi, my name is Amanda. I have a question, and this is just about like the fertilizer that I've been using on.
Sure.
So I have been our soil seems to be pretty good. We get large earthworms, but as a fertilizer, I've been using like 30-year-old horse manure.
Okay.
Um, and it's also gotten covered with some just like weeds and stuff from where we had used as a dumping ground.
Hmm.
I didn't know your opinion on that. I'm very new to all this, so I've
Sure.
just kind of been winging it before.
Okay. So the first thing I would recommend, if you haven't already, is to get a comprehensive soil test done. It sounds like your soil probably has a lot of organic matter. That's what the earthworms are indicative of. And 30-year-old horse manure is definitely going to be a good source of organic matter. My concern is that your soil may be relatively low in actual nutrients. Um, Potassium, boron, also nitrogen. So you may want to consider also applying an actual fertilizer, whether it's a fish emulsion or a balanced organic fertilizer. Or if you're not trying to go strictly organic, you can also use a synthetic product. Particularly to make sure that you get these extra nutrients in there. And a soil test will help you know where you stand on potassium, phosphorus, calcium, and magnesium, as well as boron.
Okay, thank you.
Sure. Other questions? All right. Well, I guess I will sign off and hand the microphone over to Lisa.
Thank you, Dr. Brown.
Sure. See you all next week.
Hi, Lisa. How are you?
Good. How are you?
Good. I think we'll take a 3-minute break and let everyone just stretch for a second, and then
Sure,
we
no,
can get started.
no
Okay.
problem. Yeah.
Are you all set with your slides?
I was going to say, do you want me to try sharing?
Yeah, go for it. Record. All right. Intro. All right. So Dr. Lisa Tewksbury is an entomologist at the University of Rhode Island, specializing in integrated pest management and biological control for 37 years. She's the current co-director of the Rhode Island's IPM program with Heather, or maybe Heather just retired.
Yeah.
So working with growers to utilize integrated pest management practices. She does research at the URI Biocontrol Lab, which specializes in research and implementation of biological control of invasive insects in weeds using insect biocontrol agents. Her current projects include invasive swallowworts, emerald ash borer, spotted lanternfly, and Japanese knotweed. Is that all still anything new to add to
I'll just change that I'm working on my 39th year now.
Aha.
Not sure when I wrote that, a couple of years ago.
Yep.
Yeah, and we do insect and weed biocontrol,
Great.
which is sort of said in the. But yes, thanks very much, Trish. And so I'm here to talk about sustainable pest management. And most of my career, I've been calling it integrated pest management, and we'll kind of talk about that a little bit more. But one small facet of managing pests in a sustainable way is using natural enemies, which, as the word natural says, means that they're actually naturally occurring and help us. And so we're going to talk about that a little bit too. So I'm just starting out here with a world population growth graph, kind of showing that the population keeps growing. I've heard recently that China's is not, but in general, most of the world is. And with growing population means growing food needs. We need greater food production to feed our population. So farming is obviously always been important, but maybe even more so. And so we're going to look at, what potential increased, pest pressure. What are some of the things that farmers can do to sort of meet this? And just a little example of actually one of the first plant pests that I ever worked with at the University of Rhode Island was the Colorado potato beetle. And Rhode Island grew a lot of potatoes. And I graduated in 1982 and I moved down to Delaware. And when I came back in 85, it seemed as if there'd been a major transition from growing potatoes to growing turf. And much of that was economic, that potatoes didn't bring in, a high price. But some of it was due to the pest pressure of potato beetle and other pests. So, over the years, we've kind of considered, or it has been the case, that one of the simple solutions is pesticides. And sometimes still, in our own houses and backyards, if we're kind of come across an insect problem, one of the first things we might think about is an insecticide if it's for an insect, or an herbicide if it's for a weed. But there are environmental consequences to this. So we have to worry that it's going to contaminate our water, our soil, ourselves, and then pesticide resistance. If you keep using the same pesticide over and over, that develops. And that actually is what happened with the potato beetle. All of the various insecticidal sprays that were used for them, after a period of years, and it got shorter and shorter periods of years, the beetle was able to develop resistance to it. One of the major kind of historical events between now, back when insecticides were being really heavily used during the times of DDT and everything, and then now where we're more concerned about doing integrated pest management, was the book by Rachel Carson called Silent Spring. And when she wrote that book, it was kind of a major, a little upheaval in things. Everyone thought, this is it. Insecticides protect us from, plant pests and also mosquitoes. DDT was used for mosquitoes, so many things. And she was very concerned. She was a biologist, specifically a marine biologist, and she started thinking that she wasn't hearing as many birds. That's where the Silent Spring name comes in. And she did quite a bit of research on it, and she published it in 1962. And you can see in this little clip from a newspaper article, pesticide industry folks were up in arms about this. But what it did, the publication of her book, ended up kind of sparking an environmental approach to things. This is a poster that's made about some of Rachel Carson's ideas that were in her book. She discovered that DDT did what is called bioaccumulating in the food chain. So plankton keep the toxic chemical. They're eaten by small fish, which are eaten by bigger fish, and then by birds and people. So this was a real concern. And so it was soon after that, in the 1970s, that the EPA was started, Environmental Protection Agency, to start to regulate chemicals. And integrated pest management had been mentioned in literature before that, but this was kind of the real coining of the phrase. And so here's one definition of integrated pest management, and you'll find many, but it's the intelligent. I like using the word intelligent. Selection and use of pest control alternatives, so alternatives to pesticides, is what they're saying here, in light of long-term environmental, sociological, and economic consequences. So that's a lot of things involved there. I'm teaching IPM, or I've taught it once, and I will be teaching it again at the University of Rhode Island. And we use a textbook that's gone through 7 different editions. And their definition is a comprehensive pest technology that uses combined means to reduce the status of pests to tolerable levels, while maintaining a quality environment. Okay, so reducing the pest, maybe not getting rid of it. It doesn't say eradicating, but what's a tolerable level? And then maintaining a quality environment. So that means protecting, our water and our soil and ourselves. And then here's another one, ecologically based, relies heavily on natural mortality factors. So that would be natural enemies for one, and seeks out control tactics that disrupt these things as little as possible. I just wanted to mention, I use sustainable in my title for this talk. California is moving away from integrated and using sustainable. And when you look at the, the definition, there really aren't too many changes. But I think sustainable is the way we want, we want farmers to earn money. We want them to produce a good crop. We want them to, maintain their pest pressure low. So that's all still involved. So this is some of the information that California has come out with about their strategy. And then I also have seen the term ecological pest management, and I found that both on the Xerces website. Xerces definitely is really trying to protect, the environment, to protect species that might become extinct. I think that's one of their main goals. So they protect butterflies and pollinators, and then SARE is Sustainable Agriculture Research and Education, affiliated with USDA. And so they use the term ecological pest management. So I didn't really find too many direct differences in all of these phrases that are used. So I kind of want to go through some of the, trying to think if I, okay. Feel like my order I might have in my last moving, but anyway, we'll see where we go. So one of the things in integrated pest management is to only use pesticides when you absolutely need to. And we're going to go over one of the concepts that I like about integrated pest management is it's very similar to like a food pyramid idea, where you practice prevention, choose wisely on where you, what your crops are, what you're growing on what land. Is it appropriate for growing those crops? Try to minimize pest pressure to start with. Use resistant varieties is a good way. They're not available for everything, but more and more resistant varieties, resistance to disease, resistance to insects is getting more available. And so if you do the prevention and then possibly other cultural methods that we'll go over, then you work your way to only choosing to use pesticides as basically a last resort. So in the food pyramid comparison, it would be like eating the sweets and fats and things that you're not supposed to up at the top of the pyramid. So to decide that you have a pest, you have to be looking. And so one of the real important facets of integrated pest management is insect detection. Monitoring, sometimes it's just visually, sometimes it's using a net or a trap. There's many, many different ways, but detection is really important. And then once you think you found something, you want to know the resources that are available. At the University of Rhode Island, we have a plant diagnostic clinic or plant diagnostic lab, and many of the land grant universities have this as well. And then master gardeners are also available sometimes to identify pest problems, certainly extension agents. But then there are things, we all Google everything, and Bug Guide, if you're sort of Googling and you want to know where to trust or where's a good site, bugguide.net is a really good one. And then more and more there are apps. iNaturalist has something called Seek. There's Picture Insect. If you're trying to identify a plant, there's Picture Plant. Field guides, I still love them. And so I have a lot of different field guides. And even though I can find a lot of this information online, there's something about being able to flip through a field guide that I like. Keys, not everybody likes to use a key, but sometimes if you're trying to really determine, between a couple of insects, or it's important to get an exact species, you can find a lot of online keys. And then I just recommend that, as I said, pretty much every land grant state university has cooperative extension, and many of the cooperative extension websites have publications, they have fact sheets. And so if you're choosing between, various sources, putting in, if you're putting in the words that you're Googling, the key, I'm looking at a red and black bug. If you also put cooperative extension, then you'll get some of those fact sheets about a red and black bug, like this milkweed bug here in the picture. So bugguy.net, can be helpful in identifying. You can submit a photo. Experts can sometimes get back to you. Picture insect, as I said, is one that you can, take a photo or use a photo that you've already taken. And let's see if we can show this here. This isn't a farm or a garden pest, but it's the same general idea. And so there it is. It takes you to some close ones, and you can kind of scroll down and look at the pictures. You can sort of choose if you think it's correct, and then move on. So I've been using that quite a bit. Now here's something that I've been finding. Actually, I'm in my home office right now, and these keep popping up on my laptop and next to me. And so it's brown colored, it's black and white, has black and white antennae, it has spots on its abdomen. This is an adult insect. And this is a brown marmorated stink bug, which is an invasive species, and it also likes to come into our houses. So here it is, invasive, feeds on a lot of different plants, definitely economically important crops. It's from China, Japan, Korea originally, and so is the invasive tree of heaven. So is spotted lanternfly, and both brown marmorated stink bug and spotted lanternfly feed on tree of heaven. It's one of their preferred plants. So, and here's the invade homes part, attics, crawl spaces. I've never had more than 3 or 4 at a time, but there have been places where they get hundreds or thousands, which is not welcome, as you can imagine. So here's another stink bug, also brown. And so it's similar. It's got some spines on what I call its shoulders, but it's just below the head. The proboscis is that feeding tube. This is a sucking insect, so it's got a feeding tube coming down the front of its body. And so this one is kind of a little thicker than the brown marmorated stink bug that we just looked at. So let's see if maybe we can identify what this one is. There we go. Take a look at this one closely, gives it a scan. I've just been doing this with birds lately. And there it is. It's a spine soldier bug. So the first one we looked at was a pest of plants. This one is a predator of insects. So this would be considered a beneficial or a natural enemy. So it's similar, but a little bit different, as we said before. So different insects. So here it is, beneficial predator. It attacks larvae of many economically important pests. When I look for pictures of this adult, I often find it stabbing a Colorado potato beetle larva. But here it has a caterpillar, also Mexican bean beetle larvae. So it really is, important to kind of know that these things exist, that some stink bugs are pests, but some are predators. I was actually called to a butterfly pavilion because they thought they were brown marmorated stink bugs all inside their pavilion, but it was these guys. And it turns out, as they were moving caterpillars inside, they were bringing some plants with egg masses. And so they ended up kind of growing a bunch of predators of their caterpillars, which was unfortunate. Oh yeah, this is one in action, this little video here. So another thing I wanted to talk about in terms of, you looking and being aware of the identification of your pests, it also is important to know the timing. So once you have the species that you're working with, you can learn about the life cycle, and you learn about the life cycle, you can learn about the timing and what's the best timing for treatment. So this is Heather Fobert, also from URI, and Trish mentioned that she just retired, but I worked with her pretty much my whole career. And one of the pests she worked a lot on was winter moth. And winter moth causes defoliation of fruit trees like apples, also blueberries, also ornamental plants like maples. But Heather worked closely with apple growers and blueberry growers and was kind of most concerned about winter moth's impact on them. And so one thing she ended up doing in terms of the timing was setting up this barrier. You've probably seen that people use similar barriers for things like spongy moth, which used to be called gypsy moth. When the caterpillars climb up the trees, these sticky bands will sort of catch them and kill a lot of them. Well, in this case, this is for the female. The pictures of the moths on the bottom, the male is on the left and the female is on the right. And the female has, you could either say no wings or very, very tiny vestigial wings, but she does not fly. So when she emerges as a new adult moth, she climbs up a tree and finds a place to lay her eggs. And this band will stop her and she'll lay eggs under the band or below the band. And so what Heather would do is set these bands up in November. This is called winter moth for a reason, because they emerge in November around Thanksgiving. They fly into December. And so the eggs are laid during that period, maybe by January. And then they overwinter and the eggs hatch and the tiny larvae feed into buds of all these plants that I mentioned and can cause quite a bit of damage. And a lot of times people don't treat for them soon enough because since they're feeding inside buds, the damage isn't noticed until the leaves open up and you see all the ripped leaves. And by then it's a little too late. So the timing is better when the larvae are very small, have just hatched, and you can get them before they get into the buds. And so what Heather would do is put out a notice saying, you know, the temperature we were getting to the point where we're going to get hatched pretty soon. It's actually right around now. So that can be really important for a lot of different crops and pests. And I put this in here. This is actually from NUA. I forgot to label it, but it's out of Cornell, and it's a probably it's Northeast weather app or software that allows you to get information from local weather stations. So our Rhode Island tree fruit growers had gotten a grant to purchase some weather stations. And I don't know where all of them are, but I think one's in Situate, one's in West Greenwich, maybe one's over in Little Compton. But I think there's a couple of others in Rhode Island, maybe near the airport or something. But you as a farmer or even as a gardener can get this information from whichever weather station is closest to yours. And so it allows you to get the normal weather forecast, which can help you make decisions. But it also connects to more specific information about the timing of some of the important pests. So if you say that you're growing apples, it'll give you some information about apple scab or apple maggot or a specific pest like that. So that's really helpful for timing of, any kind of management you want to do. So kind of going along with the prevention of problems, cultural control methods have been used, forever, as long as people have been farming. So I mentioned correct siting of plants. You don't want to put them in really wet areas, too close to buildings. There's many different things that are important for siting. I mentioned plant resistance, if it's available, or sometimes, just choosing to grow crops that don't have, a large complement of pests, if you can find that. Sanitation, cleaning up. This I always run into a little bit of problems because when I start talking to you about natural enemies, I'm going to say, well, if you think you have, parasitized insects that are going to hang out in your garden, then don't overdo your sanitation. So you have to kind of evaluate what you have and try to remove the things from your garden that you think are going to, cause pest problems the next year. And then crop rotation has been used a lot. And that basically goes along with the concept that pests have certain preferred crops and they tend to be within families. They'll be feed on solanaceous crops or cucurbits or something like that. And so that if you don't continue to grow either solanaceous or cucurbits over and over, then you can switch out, and your pests have to kind of, switch up and find find a new location. So this is just an example that when you buy from Burpees or Johnny's or wherever you buy seeds, you can find resistant varieties. We had to do it in our research. We were growing squash quite a bit to rear, we have colonies of insects for our research. And so we were rearing squash bugs. And we had powdery mildew was quite a problem in the greenhouse. And so we got powdery mildew resistance. And it does work, but I would have to say it can vary, the difference between 70 or 80% resistance versus 90% resistance, and sometimes they don't even indicate what it is. So it doesn't mean it's going to totally solve your problem, but it certainly is a good place to start if the tomato variety itself is acceptable to you in other ways. Then having resistance is certainly a start. Luckily, I've never pulled a dandelion with a root like that, but there's just a little example of, cleaning your tools, removing infested leaves, trying to bring in healthy transplants. All of these things help, are in this sort of prevention part of pest management. And then I already mentioned crop rotation, so something from a different plant family. So I already mentioned solanaceous, but it could also be carrots, celery, things like that. So, and then one of the pests that we have in blueberries in the Northeast, not quite sure how far it goes, but has been for quite a few years now, is a fruit fly in blueberries. But it's not a fruit fly that just comes along when fruit is ripening or rotting, past ripe, because that's the way most of our fruit flies, have been. But this one, this invasive species, spotted-winged Drosophila, the female has a ovipositor that has a little bit of like a saw blade on it. And so the female is able to infest fruit that's just becoming ripe. And so it's more of a problem for blueberry growers. So, many people in the Northeast, they're part of a working group, and they went through a number of these different methods that are here. Planting early varieties, it tends to take a while for the fruit fly population to build up. So if you can get your varieties in early and pick them, you can do that before the fruit fly really builds up into large numbers. This trap here is just a red solo cup with some holes in it, and it has like apple cider vinegar, I think, to attract the fruit flies in it just to kill them. I don't know how well that worked, but that was one strategy. Well, here it says to monitor. I think there was a hope maybe that it might also control, but it might allow you to know if you were going to try to time an insecticide. And then sanitation, of course, after you have infested blueberries. So that working group is also now working on biological control of spotted-winged Drosophila, which we're hoping to get involved with in the next year at URI. I'm sorry, I'm going to take a quick sip. I'm having a little trouble with my voice. Excuse me. So this, I just picked out, cucurbits as a way to show that you can kind of use multiple ways of management, cultural controls like crop rotation, using transplants. Sorry, I'm losing some of my guidelines here. Sometimes mulching can help. One of the big pests in cucurbits is the cucumber beetles. And so, they come into the spring. So if you use, like a row cover like this, you could keep them out for a while. Again, resistant varieties. Intercropping is another thing that involves using other plants that might repel some pests. So there's, quite a bit of interest in that, and you can find suggestions on, what plants work with what systems. So biological control is what I've been involved in for a long time. When I start talking about biological control, when I teach it, one of the things I say is that we have natural enemies, natural biological control happening all of the time. And so if we don't use pesticides at all, then the system that we're working with is the system, that's natural and that started. But depending on what plants you grow and what other controls you need, you can impact them. And so here's just a quick conservation biological control is basically the type that's very similar to just using the natural system. So the only difference is instead of, you plant a garden and whatever predators, whatever parasitic wasps or parasitic flies that you happen to have and that have found the pests you have in your garden, I mean, that's what you have. So that's the natural system. With conservation biological control, you can make decisions, well, definitely not to use pesticides. So that protects whatever you have naturally, or you can add. And while one way, that you can help is a lot of people in practicing conservation biological control will plant certain types of flowers, and that can provide additional food for beneficials. Like this is a lacewing caterpillar, or not a caterpillar, sorry, it's a larva, and it feeds on aphids. Some of these, definitely parasitic wasps, like to take nectar from flowers. So providing some of these additional food sources can attract natural enemies and can keep them and enhance the effect they might have in your farm or garden. Classical biological control is what I've been doing mostly at the University of Rhode Island, and that's something that helps an area as a whole, but doesn't work as well on a farm basis. So it's spotted lanternfly is a new pest. The USDA is working on trying to find a natural enemy that works really well in its native range, which is China, and do all the research necessary to find out if this is something safe. And they've been working on it for quite a few years now. And we're assisting them by collecting all the native insects that should be tested and providing them to them for testing. And, only after, many years of research, then the USDA is petitioned to get a permit to make that sort of a release. So like I said, that's not something that an individual farmer or, gardener can do, but it's something that once it happens, you can benefit from. So a couple that we've worked in the past were like purple loosestrife, a weed biocontrol. And it has knocked back, my main example that I was involved with is the Roger Williams Zoo. A lot of the wetland walk area of the zoo used to have purple loosestrife kind of filling in the water there. And that has been reduced to a negligible level. Another one was the lily leaf beetle. So gardeners in Rhode Island, Massachusetts, other parts of New England are having some benefits of that, but it's not something that they initiate on their own farm. Where augmentative biological control is actually adding beneficial insects, and generally that's done because they can't maintain and they can't reproduce and stay long term, which is what we hope for with classical biological control. So a good example of that is in greenhouses, we do augmentative biological control, something like this lacewing or predatory mites. And then even in farms, I think I have a picture coming up, Mexican bean beetle. It can be controlled with a parasitic wasp, and it has to be done every summer because that parasitic wasp doesn't overwinter, at least in our area. So natural enemies, when we say that, we're talking about two major categories, predators and parasites, or I call them parasitoids. You'll see the main difference is just a parasite can live with its host and not actually kill it, where a parasitoid kills its host. And that's generally when we're talking about insects, what happens. So predators are free-living organisms that kill and eat their prey. Often they completely eat it. Something like a ladybug. They're generally generalists is what I was going to say. Generalist means that they eat many different kinds of prey. So they're polyphagous or polyphagous, many things that they will eat. So a ladybug is a really good example. And you can look at it with two sides of a coin. The fact that they'll eat anything, any pest you have out there, it sounds really good. But because they'll eat anything, it means that they don't necessarily focus on one particular prey item, which if you have a lot of one prey item, that you're concerned about, one particular pest, maybe it's an issue. And ladybugs also migrate and tend to have, the predisposition to sort of fly off. So when people say, well, should I buy a whole bunch of ladybugs and put them in my garden? I generally say it's risky if you think it's fun and you're not going to be upset about the amount of money, but they'll feed for a bit and then they'll probably fly away. So other predators that are naturally existing, this flower fly or syrphid fly looks a bit like a bee, looks like a pollinator. And it is a pollinator, but it's a fly. It only has one pair of wings. And it feeds on nectar as an adult, but that little wormy maggot is a really, really voracious predator of aphids and other small pest insects like that. I mentioned the lacewing, I think had popped up in another picture. So this lacewing, some of them are predators as adults, but some of them don't really eat much as adults. But for all of them, the larva is again a really, really strong predator of small soft-bodied insects. So here's that little discussion of parasitoids or attack by aliens. Sort of the idea of that movie where something, emerges. That's kind of what happens with parasitism. So you see a small wasp in the upper right that's parasitizing an aphid. So it's using its egg-laying ovipositor, so it'll insert the eggs, and then the eggs will hatch, and the resulting larvae will feed inside that aphid and kill the aphid, and it ends up being this little mummy on the leaf. And you'll actually see when the new adult wasp emerges, there'll be a bit of a hole in it. So they're insects that parasitize other insects and eventually kill their host. So they're generally parasitic in immature stages, but they're free living like that wasp. And let's see, they are more likely to be specialists than some of the predators that I talked about. Okay, just another example of a parasitoid. This is a pest on broccoli, cauliflower. It's called the imported cabbage worm. It's that, I don't know if you can see the green caterpillar in the upper left on the broccoli. It's a very velvety caterpillar, but that's the imported cabbage worm. And that tiny little wasp. So there's a couple of different ones. There's pupal parasitoids. That's the pupa in the lower right. And then larval parasitoids, and those clumps of yellow, those are all small wasp pupae that have developed, I think, inside, and then they exit to, to form as pupae. But so that caterpillar has been killed, and this is kind of what I was referring to when I said that sometimes there are things in your garden you might say, oh, that's a caterpillar. I should be cleaning all that up and removing it from my garden. But if you leave that, that will overwinter, and the next spring, new parasitic wasp will emerge. And so it continually will then reinfest your garden. So I just wanted to give you a little idea of what a parasitoid life cycle was like. So if we start with the adults that are free living, feed on nectar, mating, the female inserts eggs into the host, and then the larvae develop within the body of the host. Mature larvae come out of the body of a now dead caterpillar and spin the cocoons to pupate. And adults emerge from cocoons. It says at a suitable time. Sometimes it might be in the summer again. Sometimes I said it might be after overwintering. Kind of depends on the species. So another parasitoid of Mexican bean beetle. But in this case, as I said, there are labs that are rearing these. You can buy them for Mexican bean beetle because we do in the Northeast have quite a problem with them. But then you would have to do it again next year and do it again the following year because this wasp, it's Pediobius fulvulatus, it doesn't overwinter in the Northeast. So it's called an augmentative, something that you add every year. We talked about a bunch of natural enemies, and lastly, we were talking about parasitoids. Adult stages of parasitoids feed on pollen and nectar. And something like this alyssum especially has really tiny flowers, which are really good for small parasitoids, like the ones that parasitize eggs. You have egg parasites, larval parasites, pupal parasites, so especially the tiny ones. And, adding flowers to your garden, has many different ways that it's useful. So it can be conservation biocontrol. It can attract pollinators. It can also just beautify your garden. And this was just a little example, floral resources for the natural enemies and pollinators. Some of the benefits, basically if you use less pesticides because you have natural enemies, you don't need to mow the field edges. Leaving the flowers, it can be natural or things that you planted. Harvesting in strips can help you, and it maintains hosts for natural enemies. And by doing this, you're providing food. And so, conservation biocontrol kind of helps because you're providing additional plants. So you have increased diversity is better over monoculture. So if you look at this, you can either have increased crops or increased, crops and flowers. But every plant that you have has its own set of herbivores or plant feeding insects, and then they have their own set of parasitoids. And so the more you can kind of build up this, food web, it ends up protecting your plants. So that's kind of one of the general concepts of conservation biocontrol. So one of the important parts of our, integrated pest management idea is to limit the use of pesticides. So you can use many of these different methods we talked about, crop rotation, other cultural methods, making sure your soil nutrients are in good shape. I heard Dr. Brown mention that too much nitrogen can increase pest pressure with like aphids and mites. Irrigation is really important. Healthy plants shouldn't be either overwatered or underwatered. Monitor for insects, diseases, and weeds, and only treat, when absolutely necessary. I just wanted, this is going to seem like a little bit of math, but I just want to talk about the economic injury level concept. So the idea is that, you get some negative physiological change to a plant host caused by an insect feeding. And then the damage is some sort of measurable loss of the host due to the pest activities. So for a farmer, it would be, some product that we're going to sell. So if you have an insect that's feeding on your strawberries or a disease that's made it so that nobody wants to buy your strawberries, then that is obviously going to cause you, economic injury. So the next thing that you'll hear a bit about in talking about IPM is the economic threshold. And that's generally the place where a farmer wants to make a decision to do something because they have a pest that has gotten to too high a level. So I don't know if you can see my pointer, but so this red line is basically what the pest is doing. And this economic injury level is where we think that, say it's the strawberries, that anything that happens to the strawberries is going to be too much damage that for us to be able to make a profit, to do well. And so this threshold is set as for a particular pest to tell you, when the numbers get this high, you need to make some kind of a control decision, because otherwise the numbers are going to keep going higher and you're going to have problems. But if you make that effective control decision, then it knocks it back a bit. So that's sort of the, one of the main ways of making pest management decisions. And I'm just showing you a few examples here of the idea that sometimes, the most appropriate action is nothing. If you have, in this case, the alfalfa caterpillar, it's a defoliator. but generally the densities are low. So this general equilibrium position is what this means. And this means that this is where the pest generally kind of, it goes up and down around this equilibrium position, and it doesn't ever get up to the economic injury level. They don't show us the threshold, but it looks like maybe this one time, maybe the threshold might be here. So generally you wouldn't need to control for this pest. Where something like this green clover worm, it's a soybean pest, it does sporadically pop up over the economic injury level. And so you would want to pay attention to the threshold in this case and maybe do some sampling so that you know if you need to treat. And another example, this is a citrus rust mite. We don't deal with citrus too much, but and this one often exceeds the threshold. And so more years than not, you might need to make some kind of treatment decision. And yeah, it causes this rusting of the oranges. And then the last one is something that's always above. That's a constant pest, something you really have to keep an eye on. So they give spotted alfalfa aphid. And early reliance on insecticide use led to some insecticide resistance. So anyway, there's a whole IPM, methods, multiple methods, including using parasitic wasps, strip harvesting, anyway, a bunch of things, because this is a regular pest. And then I just wanted to give you an example that you can find papers, research has been done on all these pests here, and probably others, to come up with these economic thresholds. So, 1 mite per leaf, trying to think if any of these are per plant, 2 larvae per plant. Most of these are per leaf or per plant. In some cases, they'll also be for traps. And so here's a tarnished plant bug, which is a pest of apples and other things. And the egg laying causes all this dimpling, which can make the apple, as you can guess, unmarketable. So this economic threshold was developed, and here it says, using a sticky trap. If you get 0.5 to 2.8 captures of a sticky trap, then you've reached the threshold, and you might need to do something about it. So I just wanted to show you, they'll set it up by letting you know like what stage of the plant to set it at, check it weekly. This is the trap you should use. So it's just a little example of how you would use monitoring in an IPM program to help make management decisions. So pesticides, we have insecticides for insects, miticides, nematicides, nematodes, fungicides, and herbicides. And the intent in a sustainable or integrated pest management program is only to use absolutely necessary and to choose the safest available for your particular situation. So there are many biopesticides, which could be considered using biological control, but because of the way they're made and they kind of go more through like the EPA as pesticides. So something like Bacillus thuringiensis, BT, is used for a lot of things like caterpillars, mosquitoes. It's treated more as a pesticide. Also fungi like Beauveria bassiana can be used. So biopesticides can be generally considered less toxic than conventional. And then even within conventional insecticides, there are safer ones. So I had somehow eliminated this at the beginning like I meant, but I can show you now that that I think this is a good model for putting a lot of care into your site and plant selection, your choice of sanitation, crop rotation, monitoring with traps, barriers, mulch if it's helpful, and then doing what you can to allow the biological control to happen, whether it's natural or whether it's something that you facilitate, and then saving that increased intervention. Yeah, if you look, it's prevention up to intervention, and then it's minimal toxicity up to toxicity. So I think this is kind of a good model. And this is where I work, and I have a website, Facebook and Instagram, and I'm happy if there's time to answer any questions.
I have a question.
Yes, hi.
What was the name of that weather app that let you know about the
Yes.
insect?
Yeah, thank you. I realized I forgot to write it on there. It's NEWA, N-E-W-A. It's out of Cornell, and I trying to think. Yeah, I think if you put in NEWA and then Cornell, you'll find it. There are many others also. I'm not that familiar with all of them. Some of them are developed for individual pest problems, and then others are more general. But as I said, this one, the Rhode Island fruit growers have decided to purchase the weather stations. And so when you're going to get data, that gives us more in Rhode Island to use. Otherwise, if you're in other states, they probably, have them as well.
A question about crop rotation. Working with like, I guess, kind of smaller plots or like permanent beds. Like if I say I've got two beds that are 3 feet apart, is that too close to be considered a rotation? Will pests easily transfer like through soil on kind of a small scale?
Yeah, so I know this is gonna feel like not a very useful answer, but I think it depends on the situation, it depends on the pest.
Mhm.
So, do you have a particular one in mind? Because it might help.
I mean, I had a huge problem with cucumber beetles last year.
Yeah, so
Fly.
unfortunately they do fly,
Yeah.
and they move in a pretty good distance. So I think a small patch isn't gonna help as much, but sometimes even if you just stopped growing something for a couple years,
Mhm.
then they've found others, and you might then get a couple of good years in without. So that's sort of the idea. If you only have a small plot of land, you can't switch it as much. You just have to kind of stop growing it if your pest pressure has gotten so high.
Yeah, I guess what I was thinking is like, say I moved it over to the other side of the set of beds I had and did floating row cover over cucurbits this year. Do you think,
Yeah,
like, I imagine they overwinter in the soil, so if I can keep them from flying into
yes.
the
Yeah, I
bed?
think, right. If you're using the floating row cover as well, I think that that could be helpful. It's worth a try.
Yeah, awesome. Thank you.
Mhm.
Dr. Tewksbury, where did you find the economic thresholds chart?
Ooh, I would probably have to look that up for you.
Okay.
Because I think that was a while ago. But yeah, so I wanted to give you even more resources, but basically, almost every land grant university has, integrated pest management. I'm a integrated pest management coordinator for Rhode Island. Katie, who's talking to you as well, I think
Mhm.
maybe after me, um, is also working with me on that, and so within IPM, there's so much research that goes on, and those thresholds are developed. The Northeast region has fruit management guides, vegetable management guides, and a lot of those will have helpful things like thresholds. And so I probably yeah, found it on one of those websites. But if you want, I can try to find you the source.
Okay. We do have the New England fruit and berry guide
Okay.
posted on our Brightspace page.
Mhm.
So if it's in there, that would be, they
It
already
very
have
well
that
may
resource.
be. It may be. Yeah,
Okay.
that's one place to look for it.
And then do you have recommendations for where people can purchase pest controls or
Yeah.
beneficial?
I think there are many, many options, and some, not too many are local. We do have a IPM lab in New York. I think it's just called IPM Labs. Um, Tim Sherman, who purchases biocontrols for our greenhouse, buys them from Beneficial Insectary, I think. There are quite a few websites. There's a person who calls herself the Bug Lady, Suzanne Wainwright Evans. who has a, I think she has Instagram, Facebook, website, the whole thing. She does a lot of kind of, supporting biological control in greenhouses specifically. It's a lot easier. I mean, there's many things set up to buy natural enemies for greenhouse use. For other things, it's a little different. Some of them still do. Some of the large companies, there's some very large. I was just reading that, most of the biocontrol agents are sold by like 5 large companies, and many of them are also involved in producing pesticides, biopesticides, and then biologicals. But say something like the Mexican bean beetle parasitoid that I mentioned, that's available at the New Jersey lab. It's a State Department of Agriculture in New Jersey has a biocontrol facility that actually produces beneficials and sells them, and they have Pediobius foveolatus. So some of the sources are kind of odd. So if you want, it's not a bad idea to kind of come up with a general list of the various things that are available. I'm part of a group for augmentative biocontrol that's trying to put together a website actually with a lot of information like that.
Okay, thank you. Does anyone have a question? Nope, I think we're good.
Okay.
Thank you so much, Dr. Tewksbury. We'll let you go.
Okay.
And
Thanks very much.
Yeah, that was
Bye.
great. Bye. All right, class. We have our next presenter. Hi, Gina.
Hi, Trisha. Now I recognize you from Women in Ag.
Oh, yeah. I don't have my overalls on, so. All right, so I think we're gonna let people take a 4-minute break and come back right at noon to get started. You guys need a break a couple minutes? Okay, great. And I will, Gina, did you send me those slides?
I did just send that.
Just now? Okay, great. I'll pull those up. I'm gonna actually hop off for just a second though. I'll be right back. Let me do, welcome back everybody. We're gonna introduce Gina Fuller from the Southern Rhode Island Conservation District. Gina has over 25 years of experience working in the environmental and conservation field, as well as extensive experience providing outreach and educational programs. As a district manager, she is responsible for building relationships with municipalities, conservation groups, and individuals to achieve common conservation goals throughout Washington and Kent counties. Gina is responsible for working with farmers to develop farm conservation plans as part of the Farm, Forest, and Open Space Act, as well as coordinating a variety of statewide agreements with the USDA and RCS. Prior to taking on a role as district manager, Gina worked in private consultation permitting large energy infrastructure projects and served as the environmental lead on several large multidisciplinary teams, taking projects from feasibility, design, and permitting to construction. I think I will stop there. You have lots more accomplishments, Gina, but we only have an hour.
That's fine. That's fine with me. I
Okay.
just grabbed what I could find in the file.
Yeah, that's great. That's great. Let me pull up your slides. I'll share my screen. Get these. Where is the button? I don't use, there it is. Okay. All right. I think we're good.
All right. So, as Trisha said, my name's Gina Fuller, the district manager for the Southern Rhode Island Conservation District. And I'm here today to talk to you about Rhode Island's conservation districts, as well as the district system throughout the country. Next slide. So the conservation districts were formed after the Dust Bowl. President Roosevelt put out word to the states after the Dust Bowl that we needed a system to manage our soil and water resources. but they wanted it to be a bottom-up system as opposed to a top-down. So the president asked that the states establish the conservation districts. And so throughout the country, the majority of the states establish districts based on the counties. So when you go to most other states, your conservation districts are aligned with the county boundaries. And in a lot of other states, counties have their own level of government. And oftentimes conservation districts in other parts of the country are governed by an elected board that runs during the general election. I like to tell people, if you watch the show Yellowstone, and they talk about the cattle officials and those folks, and that's your conservation districts. Next slide, please. So like I said, after the Dust Bowl, President put word out, nearly 3/4 of the US was privately owned. So it was really important that they establish locally run organizations to manage these resources. So our conservation districts are local government, and they are governed by a local board of directors. So I report to a board of 5 directors. They are all residents of Washington and Kent counties. At one time you had to be a landowner, but today you can be a landowner or occupier, and we'll work with you. You having a little trouble there, Trisha?
Yeah, I wasn't sure if we're both experiencing this.
Yeah, I'm not seeing the slides.
That's interesting. Oh, okay.
Got it.
You got them now. I
There
might
you
leave it
go.
in this view.
That's
just-
fine.
Okay.
And then I know what my next slide is coming up. So again, we're governed by a local board of directors. It's really important. The conservation districts were established in Rhode Island in 1944 by the General Assembly in general law. We're quasi-public. So we're non-regulatory and non-enforcement. We're here to help farmers and forest owners manage their lands and stay out of any regulatory and enforcement issues, as well as access the technical and financial resources available to you. As I mentioned, there's over 3,000 districts nationwide, and we participate in our National Association of Conservation Districts as the Rhode Island Association. And we're also a subdivision of the Rhode Island State Conservation Committee. And that committee is really just made up of a member of each of our boards, somebody from the director of the Department of Agriculture, and usually a governor's appointee for a board of 5. Next slide. So here in Rhode Island, we have 3 districts. Northern, which is Providence County, Southern, which is Washington and Kent counties, and then Eastern, which is Newport and Bristol counties. Each district's led by, like I said, a board of volunteer members, and they represent the local landowners. And they have a very important role in this larger conservation world, in that they are the voice of your farmers. And one of the things that we do is host something called the local working group. Next slide, please. Let's see where I am. So we work with a wide variety of partners. Our primary partners are the landowners, folks like you, farmers and forest owners. We also work with municipalities, conservation commissions, land trusts, anybody in the conservation world. And I had just mentioned the local working groups, which is really critical. That's the place where you, the farmer and the landowner, the forest owner, can work with us, the conservation district. Let us know what your resource concerns are, what your conservation issues are, what programs, say with NRCS, that you're working with, how they're working for you and how they're not working for you. And once a year, we have this local working group meeting, and that's the opportunity for us to take all of that input. And then we, the conservation districts, take all of that information and move it up the chain of command through the NRCS system, through the state technical committee. And we provide the voice of the farmers to help NRCS, and then DEM design next year's programs, hopefully to better meet the local needs. This entire conservation district system is about working with you, the landowner, to meet your needs, usually through federal programs. Next slide. So as I mentioned, NRCS is key. We were born together with NRCS after the Dust Bowl. And we work on things like water quality, soil erosion, flood prevention, preservation of wildlife, forestry, and good health and safety for its citizens. We have these very close relationship with NRCS, and NRCS is using US Farm Bill money to run all of these programs and host cooperative agreements with the conservation districts. That US Farm Bill money in Rhode Island translates to about $3 million a year direct into the hands of farmers to accomplish their conservation goals. And we, as the conservation district, are your partner in that. We're the one you can come to. It's always going to be here because we're all local. And we can help you, hold your hand, walk you through the different NRCS programs, walk you through those stacks and stacks of paperwork that are oftentimes daunting and intimidating. That's what we're here to do. That's one of the things NRCS has agreements with us to do, is to spend that time one-on-one with you, walking your farm, finding out what your concerns are, suggesting programs that we can help address those, and then literally taking you through every step of that process. Next slide, please. Yeah, so as I mentioned, we work really closely with the NRCS here in Rhode Island and in many other places. Conservation district staff are often housed right in the NRCS office. So here in Rhode Island, my numbers might be slightly off because we're all growing, but NRCS has approximately 30 employees in their office. And then there's an additional 10 conservation district employees who sit in that office as well, working hand in hand with the NRCS folks, going out, meeting farmers and forest owners, and helping navigate all of those programs. Next slide, please. Yep. So I've mentioned a lot of this. Our major goal is to assist landowners access that technical and financial resources. I often describe what I do. I feel like I'm like running a dating service or something. Folks call me, they've got an issue, they got to figure out how to get the help they need or those resources. And I usually can put them in touch with the right person or the right group if it's something that we can't do. So definitely encourage all of you, whether you're in Rhode Island or another state, to meet your conservation district folks and build a relationship there to help you navigate what can be really sometimes intimidating and daunting. Let's see, just as far as other items on this slide, in addition to working with individual property owners, conservation districts can be involved in a lot of other things, like educational programs. We participate with Mystic Aquarium and run a statewide after-school mentoring STEM program for students. We support Westerly's Summer Learning Initiative, which is a full-day camp tied to sustainability in the food system. And we partner with a couple local farms, take kids to the farm, take them out, show them oyster growing operations, and really let them understand what the food system is in their environment or in their towns, and how their activities could potentially impact their food system in terms of the soil and water resources. We're fortunate in Westerly that we've got a lot of great examples to be able to show kids. Next slide, please. So I know you had Cheryl and Julie here last week talking from NRCS. You may have seen this slide. These are some of the most common things we do and help farmers here in Rhode Island with. You see high tunnels, lots and lots of high tunnels going in across Rhode Island. It helps extend the growing season, deal with pest management, water management, etc. A lot of pollinator plantings happening. Soil health, of course, we have a big soil health program. And you'll start seeing in the news some talk about burying our underwear here in Rhode Island for soil health. I'm planning on making a big splash in the Southern District this year. Encouraging folks to bury 100% cotton underwear in their soil and dig it up 6 weeks later to see what kind of microbial activity you had in your soil. If there's nothing left of those undies, it means you've got really great soil health. We had a little fun starting that last year, and we're going to take it big this year. So maybe I'll see some of you. What else? We've got a manure management system, which is always a big one here in Rhode Island, since water quality is a big issue, whether you're in the Situate Reservoir area or you're down here in South County with groundwater. Managing manure and making sure it is not contaminating human water, as well as just our state surface waters, is a big concern and a priority of the state. So we spend a lot of time working with folks on managing their manure, whether it's small manure management systems or large ones like you see here. Next slide. And then I just wanted to again mention our National Association of Conservation Districts. We're very active in the National Association. Cassius Spears Sr., who sits on the Southern District Board, is also the president of our state association, is very active in the National Association. It's a great opportunity for us. We travel to the meetings. We've got connections from across the country, and it's just a great network to be able to support farmers, learn about new ideas, bring them here to Rhode Island, or bring Rhode Island ideas to other parts of the country. So I just thought it was worth mentioning the association. Next slide. That's all I really have. Does anyone have any questions? And I kind of went very fast.
I have a question.
Yes.
How do we learn more about the soil health programs?
You can reach out to one of us, or one of the better options, web-based options is on NRCS's website. They've got a great soil health page. And if you've got an active farm and you've got soil health issues and concerns, you can always schedule an appointment with your local district to come out and do some technical assistance, maybe take some soil samples, etc.
And a second question. We have, I'm in Tiverton, and we have a ton of stone walls, and over the years, the farmers, the tractors either hit them or the deer, run over them. Is there any programming for or education about like rebuilding the stone walls? Because my mother's really intent on like, don't touch the walls, don't take them down, don't touch them. But I'd love to be able to rebuild them.
Yeah, I mean, we don't really work with any programs that do that, but I can tell you there are many masons in Rhode Island that are skilled at that. I know there's several different groups, even out of the Narragansett tribe, that work with restoring walls.
Okay, thank you.
Yep.
Gina, I think that was the first I had heard of manure management systems. So is there funding for that?
Yeah, it's a practice with NRCS. So I mean, I assume
okay.
Julie and I'm blanking her name. Cheryl talked about the various programs. So that's something usually through EQIP is a practice that can be funded.
I don't think they mentioned that one, or maybe I missed it.
Yeah, and I mean, I mention it because we had in particular, the Northern District, we had a very special RCPP specifically for the small manure management systems because of the reservoir. So it is a practice through NRCS. It's just probably not one those ladies think about.
And then the other question was, oh, can you tell us about the lending library? Yeah.
The lending library is growing. We have a soil steamer, a low pressure soil steamer here in the Southern District. And we just deployed it today for the season. So this is something that the Conservation District applied to DEM a couple of years ago at the request of farmers to the specialty crop grant, specialty crop block grant to purchase a soil steamer for the use of mostly organic farmers, folks who are using high production, high tunnels. So guys that are doing a lot, and girls doing a lot of greens, things in tunnels that they need to turn those tunnels over fast, and they don't want to use chemicals because they're organic growers. So what this is a low pressure boiler. It's a big thing too, mounted on a highway rated trailer, that we bring out, and you turn it on. It's got 100-foot long steam sock. You lay that on the soil. It gets covered with a tarp. That tarp gets held down, and you pump low pressure, high temperature steam under this tarp. And what it does is sanitize the soil to a depth of like 4 or 5 inches, and it'll kill everything in the soil. And organic growers and others are like, oh, you're killing the soil health. Yes, we do. But you immediately, start feeding it with a compost. You're only killing the soil organisms that are underneath the tarp. So everything around you still is alive, and that soil will recolonize. But it knocks down weed seeds. It knocks down funguses. We have a farmer that's using it with tomato wilt, and he's very excited about that. It seems to have made a difference just in one steaming. And so that's available for anyone in Rhode Island that would like to use that by appointment. And then I will be purchasing a variety of other tools, including a walk behind BCS, a no drill seeder, some various manure spreaders, and different things through an Inflation Reduction Act agreement that we have with NRCS. In the very early stages of planning that, it's a 5-year agreement. And what we're going to do is purchase this equipment and hold demonstration events at folks' farms, particularly small scale farmers, maybe folks who have never used some of these, pieces of equipment, to actually allow you all to come out, stand behind the tractor, push it, hook it up to whatever piece of equipment, and actually try it in the field with folks that know what they're doing, in a demonstration scenario, so that when you go back to your farm, you can call us and use that piece of equipment and feel confident that you know what you're doing with it.
And do you know if other districts, other states, do they have similar programs?
They do. We got a lot of information on our soil steamer and our lending library from a conservation district in New Hampshire. And it is something that a lot of districts use as a revenue generator. We're fortunate in Rhode Island that we have such great support with NRCS and have really great agreements. Other districts have literally no funding, and they are able to support themselves by doing these kind of things, rental programs. Some of them will actually go out and they hay for people, that kind of on the ground assistance. But right now, we allow farmers to use our stuff for free. I anticipate in the future there'll probably be a deposit required. And what we'd like to do is have you haul it. Saves me a lot.
So do you have the bed that it needs to go on? It would just be attaching it to your truck? Is that what you mean?
Yeah, the steamer is on it's like mounted to its own trailer. And the other stuff we will, depending on what I'm getting, they'll either be a small trailer, it would be its own mount on.
Awesome.
Yeah.
Yeah, hopefully we can partner at URI too to get those workshops. Right? We had talked about that. Okay, great. Any other questions?
Absolutely.
Yeah.
And well, I'll just say too, the other thing that I'm realizing with this demonstration thing is I can't supplant existing NRCS contracts. So for example, we were going to do Three Sisters planting at Cassius's farm, but he already has a contract with NRCS for that. So he's got to go through with that contract. So I need to find another place to do those demonstrations. So I guess what I'm saying is once I know what demonstrations and what practices we might be looking to demonstrate, I can put it out. And if people want to possibly be the demonstration farm, we could do something there, put a cover crop in for somebody or something.
Oh, yeah.
Mm-hmm.
It's a good opportunity.
Yeah,
Okay.
I got to figure it out before they get signed up with NRCS.
So how do you have a newsletter that people can sign up for to get these?
Absolutely. The Southern District has a newsletter, and you can sign up for that at our website, which is just sricd.org.
Each of the districts in Rhode Island have a website, I think, right?
They do.
Yeah. Okay.
I know social media is a great way. We all have, like, we're all on Facebook and Instagram and starting to get on X. And we all share each other's stuff. And Rhode Island is so tiny. It's like the size of a county in other states. So there's a lot of collaboration between the three districts here. And you'll usually get the information from more than one of us. Try to reduce that, but
It's okay. Repetition is good sometimes. All right. I think that's it. Unless somebody has a question, we can let Gina go. Thank you so much.
you're welcome. Good luck, everyone.
All right. So the only thing I wanted to add was just to, if you could do your assignments that you haven't done yet. I know some of you are really good and some of you still need to do those. And I was thinking about that. I mean, obviously it's good for you to practice what we've been learning because we can sit here for 4 hours and kind of just hear all this information, but to actually put it into practice. The other side of that is I'm going to be using some of those assignments to fulfill some of the grant requirements on my end when I go to submit the reports. So, so yeah, if you can't do it for yourself, then maybe you can do it for me. So I have something to report to the USDA. And so hopefully we can get the grant again next year. And with that, I want you all to go outside. That's your other assignment for today. Hopefully all get some sunshine, get your hands in the soil if you can. And that's it. Have a good one.
Thanks, Trish.
Yep, you're welcome.
Thank you.
Thank
You're
you.
welcome.